Good day, sir. So before we proceed to our main topic, let me first introduce myself. I am Rosalie J. Loquinte, and on behalf of my co-members, namely Dona Jo A. Giritan and Tali C. Ramirez. So this subject is for the CEC 120 Intelligence System. And our project title is the license plate number recognition. So we are using the Google Colab to further demonstrate and explain our project. First is we need to install and import dependencies. This line is a install of the ACOCR and install the images. So the pip install ACOCR, the purpose of this command is to install the ACOCR Python package. So what is ACOCR? So ACOCR is a powerful ready-to-use optical character recognition tools that supports over 80 languages. It allows you to extract text from images like scan document, photos of signs, ID cards, and etc. So the pip install images. So the purpose also is to install the images Python package. So what is images? So images is a set of convenience functions to make basic image processing tasks with OpenCV easier. So it includes functions like image resizing, rotation, displaying video, streams, grabbing contours, and etc. So this is the hidden outputs. So after we install the ACOCR and the images, let's proceed to this line. So we need to import CV2 from matplotlib, import pyplot as PLT, then import numpy as NP, import images, then import ACOCR. So import CV2 is the module for OpenCV, a powerful computer vision library. So it's used for reading images, video capture, face detection, edge detection, object tracking, and more. So the from matplotlib import pyplot as PLT is this imports the pyplot module from matplotlib, a plotting library. So it's used for displaying images on charts, especially in Jupyter notebooks or the Google Colabs. So the NumPy is also used for numerical computing and array manipulations. In image processing, images are treated as NumPy arrays or pixel values. Then the import images, a convenience library that simplifies some image processing tasks using OpenCV. So common uses is for the resize, rotate, band, grab contours. So they import ECOCR. So loads the ECOCR module for forming optical character recognition, reading text from images. So it supports multiple languages and can read both printed and handwritten text. Then after, then read an image grayscale and blur. So this line is the image is equal to CV2 that I'm read Tiganaplis.jpg. The gray is equals to CV2.cvt color image CV2 dot color barang BRG2 gray. Then the PLT that I'm show CV2.cvt color gray. Then CV2 dot color underscore BGR2 RGB. So this line, this is you can insert the image that you want to read. So these lines, this image was CV2 that I'm read. Can you please see the example that we inserted? So the file name is this one, the canap list.jpg. So this CV2 I'm read is with the image using OpenCV. Then the gray is equals to CV2 that CVT colored image. This one, this converts the color image into a grayscale image. Thus the CV2.CVT color is used to convert between color spaces. Then the CV2 color underscore BGR2 gray tells OpenCV to convert the BGR color image to a grayscale image. So the grayscale image only have one channel, making them simpler and smaller. The grayscale image is stored in the variable gray. So the PLT I'm shown, this line is intended to display the grayscale image using the matplotlib's I'm show. However, it converts gray from BGR to RGB, but since gray is a single channel grayscale image, this conversion is unnecessary and may cause incorrect display or an error. So this is the example that we inserted, and the image is equals to CV2 and gray. Then the second step is apply, filter, and find edges for localization. So the B filter is equals to CV2 bilateral filter, gray, 11, 17, 17 noise reduction. H is equals to CV2 the Kani the P filter, which is 30, 100 edge deletion. So the PLT that I'm show CV that CVT color edge to CV that color underscore BGR to RGB. So this line is applies a bilateral filter to the grayscale image. A bilateral filter reduces noise in the image while preserving edges. So the parameters are 11, the diameter of each pixel neighborhood, 17 is sigma, values for color and space, controlling the amount of smoothing. So the result is stored in B filter, a smoother but still edge preserving version of the image. So these lines is applies the cutting edge detector to the filter image. It finds sharp changes in the intensity that correspond to edges in the image. Parameters are 30, lower threshold for edge linking, 200 upper threshold for strong edges. So the result is an image where edges are highlighted as white lines on a black background. So as you can see, the image. So third step is to find the contours and apply mask. So the key points is um, key points is equal to CV2 find contours. Edge copy, CV2 red 3 and CV2 chain approx underscore symbol. Contours is equal to immutals that grab that contours key points. Contours is equal to sorted contours and KC is equal to CV2 that contour area and reverse is equals to true then 10. So the key points is this function, this line explains that this function find contour, shape, or wonders in the edges detected image edge. So edge that copy is used to avoid modifying the original edge image. So the parameters are the CV2 that retrieve underscore 3. So retrieves all contours and reconstruct the full hierarchy. Parent-child relationship between contours. Then the CV2 the chain underscore approx underscore symbol. So compresses horizontal, vertical, and diagonal segments into their endpoints to save memory. So returns contour data stored in points. So this includes points that form the outlines of detected shapes. So the contours equals to immutals. So this line explains that the OpenCV find contours function returns different things depending on OpenCV version. So immutals that grab that underscore contours is a utility function that extracts just the contours list in a version independent way. So contours now contains a list of contours where each contour is a set of points outlining a detected shape. So contours sorted. So this line sort the contours by their area size using the sieve feed to the contour area from large to smallest reverse is equals to takes only the top 10 largest contours. This is useful because larger contours usually correspond to the main object or shape of interest. And these lines explains for each contour, simplify its shape with CV that approximately DP. So if the simplified shape has four corners, save it as location, then stop checking further contours because the goal is to find the first four-sided shape like a rectangle in the contours. So next is the location. So location is a variable used to store the coordinates of detected four cornered contour, usually a rectangle or quadrilateral found in a previous slope. So in short, location, this line stores the polygon points of the first detected rectangular shape. So as you can see, the result is array 715 and 488, then 833 and 487, then 835 and 525, and last is 716 and 525. D type is equals to M32. So let's continue. So here, this line, the mass is equals to NP dot zeros and create that shape and NP dot uint 8. New image is equals to CV2 dot draw contours. Open parenthesis mass station with 0 and 255 and negative 1 close parenthesis. Then a new image is equals to CV2 dot bitwise underscore and open parenthesis image and mass is equals to mass close parenthesis. So this lines explains that it creates a black image mass which is the mass of the same size as the grayscale image. So it draws the four-sided contours location on the mask in white, day 255, filling it of a negative 1. So the new image is equals to CV the 2 that bitwise underscore and in image mask is equals to mask applies the mask the original image. So it keeps only the part inside the contour. So everything becomes black. So as you can see in the image, so this part inside is the contour and the outside part becomes the black. So the purpose in this line is to isolate and extract the rectangular area, which is this example the plate number from the image. Then display new image using matplotlib with the correct color format. So the plt.m show cv2.cvt color new image and the cv2.color underscore bgr2 rgp shows that the image in the notebook script output. So visually, display the mask extracted part from the original image. Let's proceed to this next step, which is the x and y is equals to np that where that mass is equals to 255 open parenthesis x y comma that y 1 is equals to np that mean x then np mean y then x2 comma y2 is equals to np max x then np max y. So crop image is equals to x1 x2 plus 1 then y1 y2 plus 1. So finds all pixel position where the mask is white. Value 255. So the gets the top left, mean and bottom right max coordinates of the white area. So the crop image is extracts the rectangle from the grayscale image, which is this one sample using those coordinates. So the purpose is to get the exact grayscale precision portion of the image inside the detected four-sided contour. So the purpose is to properly show the grayscale image using the matplotlib.
So continuing from what we're going to discuss, so in this line number 4 is used ECOCR to read text. So in this line, reader equals ECOCR, that reader means that create an OCR reader for English text using ECOCR. So in this line, in result reader that read that text is to detect and read text from the image. So this crop underscore image, which means as storing the result. So in this number 5, which is the render result. So this text result means in this line means gets the detect test string from the first OCR result. And then here in the second line, which is this font equals CV2, that font hers say simplex, which means this line is to set the font style for the text to be shown. So in this line, CV dot two, CV2 dot pot text rather is to draw the text extracted text on the image at the position near the detected shape. So in the next line, which is in CV2, that rectangle, which means that draw a green rectangle around the detected area using the coordinates from a box. So here in the PLT and show, this means that display the final image with the text and rectangle using matplotlib. So here the result, as you can see, that the green rectangle and the extract text of the plate number.